Hello everyone, and welcome back to my channel. This is Vishnu Anjipudi, and today we will be solving problem number 21 of the 2017 AMC 8. The problem reads, suppose A, B, and C are non-zero real numbers, and that A plus B plus C equals 0. What are the possible values for A over absolute value of A plus B over absolute value of B plus C over absolute value of C plus ABC over absolute value of C? First of all, we know that A plus B plus C is equal to 0. Due to this, we can't have that all of A, B, and C are greater than 0 or all of A, B, and C are less than 0. This is because if A, B, and C are all greater than 0, then their sum, which is A plus B plus C, is also greater than 0. But this means that it's not equal to 0, which is what we want. Similarly, if all of them are less than 0, the same logic holds. Thus, we can consider two cases. Case 1 is when two variables are positive and one variable is negative. And note that we haven't actually specified that which variable is greater than 0 and which variable is less than 0. This is because it does not matter. If, say, C is less than 0 and A is greater than 0, we can simply swap the values of A and C, and the result will still be the same. Thus, it does not matter which variable is which. So here, we see that when we have two variables are greater than 0, we can assume, without loss of generality, or W log, as it's generally abbreviated in the mathematical community, we can safely assume that A and B are the variables that are greater than 0. Because, as I mentioned earlier, if C is greater than 0 and B is not, you can just swap C and B, and the result will still be the same. So then, in this case, we have that absolute value of A equals A, since A is greater than 0. Absolute value of B is equal to B. And absolute value of C is equal to negative C. Thus, we know that A over absolute value of A. And also, by the way, note that these conclusions, where A plus B plus C is greater than 0, were derived because we know that A, B, and C are non-zero. Otherwise, they could be 0. But since there's these denominators, we know they can't be 0. So A over absolute value of A is going to equal to 1. Same as B over absolute value of B. And now C over absolute value of C. So C over absolute value of C is going to equal to negative 1, since C is less than. Thus, we have that this value, in case 1, is 1 plus 1 minus 1, since we know A over A, absolute value of A, B over absolute value of B, and C over absolute value of C. And now we're left with ABC over absolute value of ABC. Since A, B are greater than 0, while C is less than 0, we know that ABC, or A times Z times C, is also less than 0. This means that absolute value of ABC is actually just equal to negative of A, B, C. Thus, we can subtract another 1, since ABC over absolute value is negative 1. And we get that case 1 gives us a result of 0. Now, let's look at the second case. And by the way, since we know that there's only 2 cases, we could technically eliminate E and D simply because there's only 2 values. And we can eliminate C and B because they don't include 0, which we just found. So technically we already know that the answer is A. But just for making sure that we actually got the answer right, let's just work through the other case and see what we get. So now, in the second case, we have a similar thing. This time, let's do case 2. And now we can have another without loss of generality, because the same symmetry logic applies. So, without loss of generality, A is greater than 0, B and C are less than 0. Okay, they're less than 0. Sorry if that's messy. Okay. So, we know that by similar logic, absolute value of A equals A, while absolute value of B equals negative B, and absolute value of C is also equal to negative C. Yeah. Thus, we have that this expression is equal to A over absolute value of A, 1, plus B over absolute value of B, negative 1, plus C over absolute value of C, which is also negative 1, and then ABC over absolute value of ABC. Now, we know that since B and C are less than 0, the product of B and C has to be greater than 0. And since A is greater than 0, that means the entire product is greater than 0. So we thus know that ABC is equal to the absolute value of ABC. So we know that we can add another 1, and lo and behold, this is also equal to 0, verifying that answer choice A is indeed the right answer, and we are done. Thank you so much for watching this video. It really means a lot. Please don't forget to like, share, and subscribe, as well as click the bell icon. As always, if you have any questions, comments, or concerns, please post them down below or email me at cnaspirations@gmail.com. This is Vishnu Manjipudi signing off. Bye.